So my name is Jennifer Gilbert, and I am the product owner of the NLM Digital Collections. And I'm joined by my colleagues, Calvin and Doran. We all are part of the Digital Repository Working Group. So we're going to give you a couple updates. And I'm going to go first. And today I'm going to share with you briefly the NLM Digital Repository software selection process. In this case, for a new page turner for the thousands of digitized books and other textual resources in digital collections. A little history on our project turners, which we also call the book viewer. Currently, and since 2018, we have been using the open source book reader developed by Internet Archive. This replaced the book viewer software from Northwestern University that we had been using since 2010. Last year, the user experience team, which is part of the repository working group, decided to take another look at the available software for a few reasons. For the most part, the book reader does a good job displaying printed books, but we are getting more material in the modern manuscript collection, and that material comes in mixed dimensions. And we discovered an issue in those cases with the aspect ratio not displaying correctly in the two-page view. So one page would be stretched out and unreadable. Also, the IA book reader license is more strict than other open source options. Another consideration is we are required to migrate to the cloud soon. So here's an item from our Incunabula collection displayed in the IA book reader. Aspects of the book reader we like and require moving forward are flipping and scrolling through the pages, zoom, and download of the resource and its metadata. I will speak more about requirements shortly. Here I'll provide an overview of our approach. Everything was documented on the wiki, and all presentations and meetings were recorded so that the entire staff would be aware. And for that we used Microsoft Teams. Our team lead started with a list of requirements of features that required. And then we grouped them by priority. The high priority features include page display, search features, zoom, and graceful handling of different page sizes, such as foldouts. Also important is 508 compliance, download of PDF, OCR text, or single pages, HTML5 and IIIF compliance. Medium priorities include navigation of structural contents, multiple language support, annotations, and integration of search with Blacklight, our user interface. Then group members added a list of their favorite applications and noted the strengths and weaknesses, etc. We discussed the list as a group and settled on 4 top picks. Our developer on the team did a technical review of these to make sure our choices were feasible within our established infrastructure. We included IA Book Reader because we are familiar with it and we have done some custom coding. Mirador and Universal Viewer. Tiffy was eliminated at this point because of the lack of search functionality. We also decided on examples, use cases from our collection. And here is one of our resources, an Army Cadet brochure. This is in the native Mirador 3 interface. This is an example of a couple of our use cases. So a 2-sided item and mixed dimensions, which you may be able to see in the thumbnails that there are different page sizes. Again, this is out of the box Mirador, and we noted during our evaluations which features are customizable. And here is one of our archival documents displayed in the Universal Viewer. This is from another project at NLM that has already deployed Universal Viewer. This is a notebook of Rosalind Franklin, a chemist and X-ray crystallographer whose work was central to the understanding of the molecular structures of DNA, RNA, and viruses. Moving on in the process, 3 team members volunteered to be a champion and do a detailed analysis of one of the applications. Our team lead converted the requirements list into a matrix so we could fill in a score for each feature. And you can see the possible rankings in this box over here. In addition to the high and medium priority areas, we also evaluated what we call potential requirements, aspects that could have an impact, such as licensing restrictions, supporting server tools required, cost, intangibles, so any wow factors that are hard to quantify. We also discussed and recorded our thoughts on additional use cases, such as images, born digital, multiple volumes, 3D, etc. Our developer ranked 0 to 3 on technical considerations, including system integration, security standards, cloud readiness, maturity of the software, etc. After giving the software champions a few weeks to prepare, the team held a session for each software. The champion demonstrated the features using our agreed on use cases. As each requirement was discussed, the champions shared their opinions and the group weighed in on a ranking, and the majority score was recorded in the matrix. The scores were added up, and the winner is Universal Viewer. It was close with Mirador, but scored higher on top priorities, specifically full screen viewing, downloading, image manipulation, and multiple page views. The group preferred Universal Viewer because it handles basic image display well and excels in the wide range of media it can display. It functions well out of the box and is being updated with useful features and allows for customization to fit specific needs as well. So the team lead drafted a recommendation, which was shared along with the demos to the whole working group. We held a vote and the Universal Viewer was selected unanimously in December. Currently, we are in development and we expect to completely replace the IA book reader with Universal Viewer in May or June. And that's all I had for now. In the interest of time, I'll stop sharing and let Calvin share his presentation. But thank you everyone for your time and attention, and I can answer questions at the end, or you can always find me on Slack.
Hi everyone, so today I'll be spending a few minutes talking about NLM's current migration update and our current findings, as well as I guess some tips and tricks we find that works for us in this process, and hopefully will work in your implementation as well. So to start off, my name is Calvin. I am the developer at NLM Digital Repository Working Group on Doran's and Jennifer's team. NLM is one of the pilot groups in the Fedora 6 development. So we are actively engaging and testing the releases from the Fedora 6. So far it's been going well. We have tested quite a few runs on the migration tool, utility software, and provide them, the developers, with our feedbacks and benchmarks we observed during our testing. So first, I will briefly talk about our Fedora 3 repository content that we have for this migration effort. Currently, Digital Repository is hosted on Fedora 3, has about 4.7 million objects. Most are the page images scanned from books in TIP format, and they are stored in Fedora in a Fedora legacy storage format. And we also have 3.8 million historical citations XML objects in Fedora Akruba storage format. Most of our binaries are type E external, and each object has multiple data streams. So our total binary size for all the contents runs about 75 terabytes. And I provided the link for our collections UI. As you can see on the screenshot here, it's just one of the page objects that we have, as well as the data stream that's associated with. So as Scott previously gave a great detailed presentation about the migration utility, I would just iterate once more. So the migration tool iterates over the proximal files of Fedora User Repository and creates a Fedora 6 compliant OCFL structure for each of the objects. So to iterate once more, OCFL stands for Oxford Common File Layout. It's emerging digital standard for digital repository system on how files should be laid out on disk. And it's also a big part of the Fedora 6 and in adopting OCFL. The migration utility requires Java 11 to run, and the command is expecting you to pass in the parameters such as the data string directory of Fedora 3, the Fedora 3 object directory, the target directory where the OCFL structure will be migrated to, and as well as other parameters such as you could have continue on air when processing the migration if you're doing a large number. Also, you can check off option like checksum validation so that it processes faster. So here we see the migrated example after it's been pushed through the utility. As you can see by the structure of the migrated content, it is conform to the OCFL specification. And here's the with the SHA-512 checksum on the object group corresponds into the info/Fedora object ID, so that the Fedora container resource maps to a single OCFL object. Here we see the item in the content folder that corresponds to the Fedora 3 data screenshot that I showed earlier. So here's side by side. As you can see, the data string binaries that are in data string control group B, such as the master data string, the alto, and the OCR, and thumbnail are not, the content itself is external, so it's not migrated, but the Fedora 6 does store the description about it, so it knows about where the item is in reference. And also for data streams such as the OAIDC and the RelX, the XML files are in control group X, so they are migrated, so you can just view them in text. So our benchmark, we have run migration tools throughout the development process since the pre-alpha and alpha, now post-beta, for all our contents. We observed that in earlier alpha version, it took about 7 to 10 days for a full migration run on the 4.7 million objects in flat legacy source layout for Fedora 3, and about 5 days to migrate 3.8 million Fedora Aruba storage format objects. And we are running this in our CentOS 7 machines with 8 gigabytes of RAM. We also observed it uses about 30% of CPU utilization and 30% of the memory utilization. However, in the post-beta migration utility, we observed that it migrates about 30,000 items per day and utilizes 3% in CPU utilization and 38% in memory utilization. And currently, the Fedora team is looking into the performance drop there. So the challenges we have in the running the Fedora migration is the inode shortages. So before when we were doing the full run, we quickly realized our inodes were running short. So we added about 500 million more inodes volumes in to support the migration. And yeah, just keep on cleaning them out at the end of each full migration. And sometimes it takes like days to just delete all those inodes. And as I said before, I think post beta has a slight performance drop, and we were able to tune it with increase in Java heap size when running the utility from the default 1 GB to 4. That I guess gives the process about 10% memory boost. And also, it's worth mentioning we also turned off the checksum validation switch, so that gives it about 5 to 10K boost there as well. And also another thing people could do to increase the performance is to switch to, instead of using SHA-512 hashing algorithm, use the SHA-256, which I think is both OCFL compliant. But it just probably calculates faster with the SHA-256 there. So our future directions is to analyze whether and how to migrate the external binaries into the OCFL structure so that you can view it on the Fedora 6 UI, and also do the metadata mapping from custom XML in the Fedora 3 to RDF for Fedora 6 linked data platform, as well as identification of procedure to validate the migration, which will be introduced in the validation tool that's currently being rolled out. So yeah, that concludes my presentation. And any questions? Thanks for your attention.